Alright, so for this video we're going to specifically go into our photoreceptors and how the on and off part work. Okay, this is going to be fun. Alright, okay, so first you have your photoreceptors. Okay, and then you have a bipolar cell. And then it's going to send a signal through a neuron to your brain. Okay, on your photoreceptor, first thing to note is light decreases glutamate. That's what we care about here, okay? So you've got a G protein coupled receptor here. Okay, that's gonna go and it's gonna activate a phosphodiesterase. There's a channel that's always open if you have cyclic GMP on it. So if you have cyclic GMP, that channel is gonna be open. And then over down here, you've got your calcium channel, your voltage-gated calcium channel, and you're going to have all of your, neurotransmitter stuff with the snare proteins and all that jazz, okay? So inside of here, you have something called a cis 11 retinol. But light turns it to trans 11 retinol. Trans 11 retinol is going to activate this, which is going to send it to the phosphodiesterase, which is going to turn this on. The goal of the phosphodiesterase is to break down cyclic things. So this is going to come, it's going to break that, which is going to shut that. Okay, so now you can't get an action potential and you cannot release glutamate. That's the first step. There's two types of bipolar cells. You have a bipolar cell with a G protein called the mGlu-R6, and when that's active, it closes this calcium channel. And then you have an AMPA receptor over here, and then you have got your calcium over here. So I'm drawing it on the same cell, but that's not how it works. There's technically two different bipolar cells with these two different receptors, okay? So, no, we hit it with light, okay? I'm gonna do more of like an orange so you can see. So there's no glutamate released, okay? No glutamate means this can stay open. So I'm going to be able to release my receptors from here, which means that I'm gonna get an action potential, okay? So light for my mGlu-R6 means I get an action potential. Over on my AMPA, I don't get anything binding to this, which means I don't get an action potential, which means I don't get anything here. So light, when I have an AMPA receptor, means no action potential. Okay, then we're gonna have our no light option. Without light, right, this stays open, so I can have my positive charges rush in, which means I can have a blanc, which means I can open this, and I'll release glutamate. Okay, glutamate binds to this, which causes this to go and shut that. So I will not release this because this won't get to the blanc. So no light or dark equals no action potential if that's the receptor. Over here, my glutamate will bind to my AMPA, I'll get a blanc, I'll open this, and I'll get this, which will bind and send an action potential. So no light over here will mean I have an action potential. So now we have our off-center versus on-surround. And it's almost the same thing as this. Okay, so let me delete this and we'll refer to the drawing in a little bit. Okay, So let's say that we have 3 cells. We've got a horizontal cell. Okay, we're going to call this an on center and an off surround. And then you've got that. Okay, on center means that you have M glue R6. Off center means that and this is on the bipolar cell. They're both in the bipolar cell. Off is AMPA. Okay, so you've got your M glue R6 and the calcium channel that's usually always open. And you've got these neurotransmitters. I'll show you what that means in a sec. Okay, so let's say, I'm not going to put light on all of it. Let's say we just put light over 2 of it. Okay, let's start with the on center. Alright, light hits it, meaning, okay, I close that. I don't release any of this, but it's M glue R6. So I'll keep this open and I'll get an action potential. Okay, so I get an action potential. So I've got an action potential, increased action potential through here. So I'm going to say that there's 6 action potentials here, 2 action potentials there, 2 action potentials here. So I'm going to get 6 action potentials. Okay? Now on my off, light always decreases glutamate. Okay? So I don't get glutamate through here. So I've decreased glutamate. Which means that I'm going to have through my horizontal cells decreased GABA. GABA is inhibitory to glutamate. So if I have less things that inhibit, I'm going to have more things that are activated. So I'm going to have increased glutamate, which if I increase glutamate here, right, it'll bind, I'll shut this off, and I don't get an action potential. So I got nothing from there. Decrease action potential there. Okay, over here, okay, I decrease my glutamate, which means I have, oh wait, sorry, whoops, beep, 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 boop, boop. There's no light over there. Okay. So no light means that I have glutamate. So I'm going to have increased glutamate, which means I'm going to have increased GABA, which means I'm going to have decreased glutamate because it's the inhibitory. So I'm going to inhibit, really decrease my glutamate, which means that I will not bind here, which means this will stay open, which means I'll get an action potential. So I'll get 2 from there. So my tick marks, 1, 2, 3, 4, 5, 6, 7, 8. It would look like that. Okay? That might not have made sense to you, but it makes sense to me, and that's all that matters. Okay? If I was doing the off center, it would be AMPA as my receptor, right? So having decreased glutamate would be a bad thing because then I couldn't activate my bipolar cell and release that. Is that all? There's 2 types of photoreceptors. It's rods and cones. They do like the same thing. Explain how center and surrounds cooperate in visual field. I just did that. Basically, this idea of having 2 receptors, one that sends action potentials when there's light and one that doesn't send action potentials when there's light, lets you figure out how bright it is or how dark it is. Okay, and I'm pretty sure that's it. So that's the end of this video and the end.